Good afternoon, everybody. Good afternoon, Disha, Mautulika. Ashman, good afternoon. Dilgachwan. All of you have seen the video. Good afternoon. Yes, Ashman. Thank you. If you have any doubt, please ask me questions related to this uh, problem. Right? Definitely, you can ask any other questions also, but definitely related to design here. Now, all of you are requested to make a profile picture so that we can see you from this live chat session. Okay. Otherwise, within after mid semester, you will not be allowed further. It is an instruction from the higher authority, right? All of you requested to do this. That is actually good for you, so that we can identify the bad people from this live chat session, right? Because some outsiders are coming into the live chat session. Sometimes they are disturbing. Okay. Now, start asking questions if there is any doubt regarding this or any other doubts. I'm asking all of you one question that um, you see for the given problem, what I have discussed in the that video, that um, in terms of order, if you want to consider the asymptotic complexity like in order means if some algorithms complexity is c times n, c is a constant and n is the input size, then it can be written as it is belonging to order of n, right? You see this, both the algorithms, the improved algorithms behavior also order of n, and the previous algorithms, first algorithms behavior is also order of n. Till you see this, but in the actual scenario, in the first algorithm, you have to do two times the scan, and in the second, you have to do only one time scan. And the most important part is here, the, that what is the lower bound of for solving this problem by any design or by any algorithm. इस दुनिया में जितना सारा एल्गोरिदम है हो सकता है, कोई भी एल्गोरिदम का व्हाट इज द लोअर बाउंड. Yes, I am asking. अच्छा, आयुष कुमार पांडे sir, can we two array, one for traversing and other for to zero? Yes, yes, yes. You are absolutely right. Actually, one for traversing the number of zeros or ones. Suppose you want to count first the number of zeros. If you can count the number of zeros is c, then n minus c is the number of ones. Then again, you have to put all the zeros in a c number of zeros on the left side, and after that, one will be put. N minus c, one will be put. So the two scans are needed. You are absolutely right to do this. And the last algorithm, it can only be done by one scan. And that why what I want to tell, what is the lower bound? Lower bound means actually suppose you have designed one algorithm, its behavior is order of n. You cannot tell that it is the optimum algorithm. When you can tell that it is an optimum algorithm, optimum means this is the best algorithm. That means इससे कम नहीं हो सकता है. That means order of n से कम नहीं होगा. That means at least one time scan must be needed. Why? As all the data zero ones are in random order, so you have to see all the elements in that array positions at least once. You have to see, because how many zeros are there or how many ones are there, you have to count in any way. You have to see, that means at least n times you have to see all the elements for those n array positions. So this is the, if for so the from the designer point of view, the if the designed by any person, it's lower bound at least n. That means you have to scan the whole array at least once. That means order of n must be needed at least. And your algorithm, last algorithm, you see what I've told in this video, by one scan you have done this job. This is your algorithm, right? That means your algorithm is optimum, because that lower bound theory will give you the intuition behind this, that with it can be done in uh, only order of n time, that is optimum time. Clear? Any more questions, please? Any more questions? The questions may be related to the or any other. No problem. You can ask any question. Aditya Poddar, Aditya Poddar, you have seen this video? If yes, just write on yes here. Ronita Das, you have to add your profile picture here, right? Acha, why you want to get answer from Aditya? Where is Aditya? Any more questions? I want to ask one question, that is, have you at all seen the video? I want yes or no answer from all of you. Ashman, you have already told me that you have seen the video, right? Uh, yes, yes, yes. Sir, how to separate zeros on the oh, how to separate Rajdeep Ray, to separate zeros on the left side and ones on the right side of the array by traversing the array twice. Can you explain it once more? I can't understand you. But just you see, Rajdeep Ray, suppose some zeros are there and some ones are there in the array in random order. Just you can just I'm showing you to see this. Suppose 0, 1, 0. Have you seen this? Yes. 1, 0, 0, 0, 1. Suppose this is this thing. So you have to write for loop for I is equal to definitely it is the starting point is 0, 1, 2 like this. So I is equal to 0, I less than equal to less than n and I plus plus. What you have to see? If ai is equal to 0, I am not writing the exact syntactical thing in C. Okay, if ai equal to 0, then count plus plus. Am I clear? So initially you have to write here int count equal to 0. Initially the value of count was 0 and count plus plus. That means number of zeros will be counted here. If it is C, then how many ones are there? N minus C. You don't have to count 1 again. Now those 0 will be put here. Then again you can write here another for loop. Again you have to write another for loop. The for loop is remain same, and you have to put I is equal to I equal to 0, I less than C. Am I clear? Rajiv, you see this, as you have already counted this number of elements is C. That is, here it is not C. You should write here count, because here the count is there, right? And ai equals to 0, right? The up to from 0 to count minus 1 position, 0 will be stored, and you have to write another loop from count to n minus 1, put all the values as 1. So this is the second scan, right? I think it is clear to you. Rajiv, it is clear? Is it clear to you? Okay. That's why two scans are needed by the previous first algorithm. And second algorithm, your left pointer is moving towards the end point, and second right pointer will be moving towards the beginning point, and somewhere it will meet. That means the algorithm will run till left will be less than right. At that moment, when L equal to R or greater than R, then the algorithm will stop. That means the ultimately suppose left pointer will move R places, then definitely the right pointer will be moving n minus R positions. The total number of positions, movement positions is basically n minus R plus R, that is n. So the complexity is exactly order of n and equal to n also, right? This is the case. That's why it is order of n, and that lower bound theory will give you this is purely optimum. The second one, this is purely optimum algorithm. This is the best algorithm. No one can design better algorithm than the last algorithm. Your algorithm may your algorithm's behavior may be different, but its complexity cannot be decreased by rather than less than n, right? So you can design more algorithms in several ways, but your complexity cannot be decreased to less than n, right? That is the main point. Any more questions? Gaurav Kumar, where is your profile picture? Gaurav Kumar doing it. Okay, okay. Do this, please. Because it is an instruction from higher authority. In fact, it will be helpful to you people. Some people are there who is outside uh, your class, so that we can track those notes, right? Uh, I am giving you 2 minutes more time. I'm waiting. If there is any question, please ask me. Otherwise, I will end the streaming, right? Any more questions? Only 1 minute remaining. Can anyone tell me, is it a easy problem? Or so that I can tell you the harder problems? If you want, I can tell you the beautiful problems, but some more harder things are there. Whether you'll enjoy it or not, I don't know. Because some prerequisite knowledge will be required to do that harder problems, right? Okay, give the IMCRP test and complete the assignment. Okay. Okay, complete the. Thank you, Ditesh. Sir, hard, no sir, hard question not required, sir. Slow and steady. There is Rajdeep. Okay, okay. Rajdeep, thank you. We'll go slowly, definitely. This is moderately easy. These are moderately easy. Yes, for some of you, it is definitely easy. And for some people are there who are not at all familiar with any programming languages. Actually, if you know the programming languages, what facility those programming languages will provide you upon upon knowing those things, you can solve the problems by designing algorithms. And it too competitive, sir. Really love that. Okay, I will next time. Next week, possibly next week is the mid semester exam. Next week, mid semester exam. Then proceed to harder slowly. It is okay. It can help in competitive coding. Definitely, definitely, I will help you. Definitely, I will help you. Uh, it's, next week mid semester exam. So next week, definitely, I'm thinking for some problems. It is more challenging, more logical things will be there, and definitely some more mathematics will be there also. Okay, the good algorithm means more mathematics, less coding, right? That is the beauty challenge of this. Okay, thank you very much. Enjoy. Enjoy the mid semester exam online possibly. Okay, thank you very much.